The Venera or Venus missions in Russia were launched between 1961 and 1983 to investigate the second planet from our solar system. 13 of the 28 spacecraft launched reached Venus's atmosphere, and 8 successfully landed on the planet's surface. Upon its launch, the Soviet program established multiple firsts, including the first probe to enter a planet's atmosphere other than Earth, the first spacecraft to land softly on another planet, and the first mission to return photographs and sounds from another planet's surface. So far, more than 1/3 of the 30 space missions that have successfully flown past or orbited Venus have been part of the former Soviet Union's Venera series of robotic probes. Shockingly, the Soviet has kept several of their discoveries on Venus hidden from us until now. Could there be presence of life on the giant red planet? Stay tuned, as you are about to find out. Let's take you down memory lane to where it all began, with the successful launch of Sputnik, the world's first artificial satellite, developed by the Soviet Union in 1957. The space race between the United States and Russia increased. Both countries vied to set new milestones, such as sending a spacecraft to the moon or exploring other planets in our solar system. The Cold War-era space rivalry drove the Soviet Union to contend with the United States in the 1960s, as the first country to accomplish critical milestones in space exploration. The Soviet Union regarded space exploration as a means of demonstrating its scientific might and promoting its ideology on a worldwide scale. Venus was an especially appealing target for study at the time, since it is the nearest planet to Earth and has a comparable size and composition. Since little was known about Venus at the time, the Soviet Union saw the successful investigation of Venus as a great accomplishment and display of its scientific and technical capabilities. The Pioneer and Voyager probes, which the US sent to study the outer planets in the 1970s, are often and correctly hailed as momentous interplanetary successes. This is partly because, like the Pioneer plaque and the Voyager golden record, these artifacts are presumably designed to be discovered by aliens someday, allowing them to readily burrow into public awareness. Similarly, robotic explorers to Mars, such as the Viking landers, and the Sojourner, Opportunity, Spirit, and Curiosity rovers, get many headlines and are often given anthropomorphized characters. However, the Russians were keen to achieve as many firsts as possible in all areas of spaceflight. They possessed a greater heavy lifting capacity than the US at the time. This enabled them to design and launch bigger human-crewed and uncrewed spacecraft. Starting in the late 1950s, at the advent of the space age, the Soviets sought to develop and build a series of Venus probes. Thus, as part of the Venera program, they constructed and piloted the interplanetary spaceship for almost 30 years, accomplishing rather astounding accomplishments even by today's standards. The Russians also launched missions to the difficult-to-reach inner planets utilizing 4-stage rockets and a complex telemetry system. The Soviet Union's Venus missions was a group of spacecraft established to investigate the planet Venus. Venera 1, the first mission, was launched in 1961, but failed to reach Venus, owing to a problem with its guiding system. The second attempt failed en route to Venus, although passing within 62,000 miles. Venera 2, which resembled Venera 1, was designed to fly by Venus, recording and transmitting data to Earth. The probe completed its flyby in 1966, coming near 15,000 miles. It's uncertain if Venera 2 failed before or after passing through the other planet, as it couldn't communicate due to overheating. The following 4 probes, Venera 3 through 6, were developed by the Russians to explore the atmosphere of our hellish neighbor more carefully. Typically weighing about 2,000 pounds, these probes carried equipment and a detachable pod known as a descent module, outfitted with a second set of instrumentation, such as a barometer, radar altimeter, gas analyzers, and thermometers. Yet not all of these investigations were successful. Venera 3 was the first spacecraft to reach Venus's surface. However, it crashed upon landing in 1966, making it the first spacecraft to do so. In 1967, Venera 4 discovered very high quantities of carbon dioxide in the atmosphere, and the absence of a worldwide magnetic field. Sadly, after roughly 90 minutes of gathering measurements, it gently drifted down into Venus's thick atmosphere, where it met its death due to the planet's extreme heat and pressure. Venera 5 and Venera 6 were also successful, sending data for more than 50 minutes when they parachuted into Venus's atmosphere in 1969. By assisting scientists in further characterizing the world's atmospheric composition, these probes demonstrated that Venus is exceedingly improbable to harbor life. Romantic notions of Venus as an earthly paradise were smashed. Subsequent flights such as Venera 7 and Venera 8 successfully landed on Venus and transmitted data back to Earth. These missions produced important information on the planet's atmosphere and surface conditions, including severe temperatures and pressures. Venera 7 had an even more ambitious descent module meant to land softly on Venus, complete with substantial defense to withstand the harsh conditions on the surface. Initially, it failed, although it managed to relay essential data for a brief time. The lander registered a surface temperature of over 900 degrees Fahrenheit. Despite the failure of the probe's pressure sensor during descent, researchers were able to estimate a surface pressure of around 92 bars. Venera 8 replicated most of the Venera 7 mission in 1972, but without the lander collapsing on the surface of Venus. Venera 8 was outfitted with equipment for studying Venus's atmosphere and surface. The spaceship carried a lander meant to descend through Venus's dense atmosphere and land on the planet's surface. The lander fell smoothly through the atmosphere and settled on the surface, sending data back to Earth for nearly an hour until its batteries died. According to the data returned by Venera 8, the surface temperatures on Venus was over 470 degrees Celsius, and the pressure was around 90 times that of Earth's atmosphere at sea level. The Venera 8's working pressure sensor verified Venus's oppressive atmosphere. Still, it also measured ambient light levels on the surface, indicating that future cameras should be able to record the Venusian sights. Venera 9 through Venera 12 are the most remembered Soviet trips to Venus since their landers carried cameras capable of directly imaging the planet. The early Venera 9 and Venera 10 images are disturbing. They represent a rugged, rocky alien terrain spreading out to the horizon, crisp, sharp, and spherically deformed by their wide-angle lenses. But the photos also captured the lander's margins, revealing their obviously Soviet design. Venera 13 and 14, both launched in 1981, were more advanced renditions of the Venera 9-12 probes, carrying landers outfitted with sophisticated acoustic equipment that could tune into the Venusian wind and measure its speed. Venera 15 and Venera 16 spacecraft did not carry landers. They replaced them with powerful radar-based imaging equipment capable of mapping the scorching Earth from eccentric orbits. The Pioneer 12 probe was the first to map Venus using radar. However, Venera 15 and 16 did it better, with around a mile per pixel resolution. These probes' photographs were very detailed, exposing vast expanses of the harsh environment, replete with impact craters, steep elevations, and lava-flooded basins. Many cameras on these probes failed while visiting Venus between 1975 and 1978. Typically owing to their lens lids falling or coming off. Yet a few people could capture and send the first photographs from the surface of our solar system's second planet. The Soviet Venera program remains the most rigorous and long-running sequence of trips to Venus. Thankfully, the Venus missions were critical in advancing our understanding of Venus, including its atmosphere, surface conditions, and geology. The data collected by these missions have helped scientists gain insights into the extreme environment of Venus and its potential for supporting life. We are now fully aware that Venus and Earth are not the same despite being neighbors. Venus has an atmosphere nearly 100 times thicker than Earth's, with very heated surface temperatures. Venus, unlike Earth and the other planets, rotates backwards and does not contain life or seas of water like Earth. For further research, Roscosmos, Russia's state space organization, is designing the first new Venera mission since the Soviet Union's demise. Venera D, scheduled to launch in 2029, will feature an orbiter and a lander and serve as a model for future Venus missions. We hope you enjoyed watching this video. If yes, we're sure you'd like this next video here. Thanks for watching.